Okay, this is lesson 4-4, scatter plots and lines of fit. So on this, when it says scatter plot, okay, that is a graph that just shows the relationship between two data sets. So they're graphed as ordered pairs. You just don't draw a line through them. So for example, it typically is best when you have a whole lot of data. Like looking at this, it's the age of married couples. When the wife, how old the wife is versus how old the husband is. That was their ages when they got married. So it typically works best when you have a whole lot of data. For example, if I wanted to put like everybody's test grade, that would be a good way to do that, to kind of see the average and see if there's any kind of relationship happening. Okay, so first thing we're going to look at, if you want to write that down, you can. I'm not going to make you, but I just think of it as a scatter plot is a plot of a whole bunch of scattered points. Okay, but if you want to write that down, it's the relationship between two data sets, just as a whole bunch of graphed points. Okay, the first example, interpreting it. So this tells us that the scatter plot shows the amounts X in grams of sugar and the numbers Y of calories in 10 smoothies. Okay, so we're looking at this one right here to the left. Sugar in grams is our X, calories is our Y. So they just ask us questions about it to see if we can interpret this graph. So it says how many calories are in the smoothie that contain 56 grams of sugar. So we would come down here and find 56 grams of sugar. Go up, that would be 270 calories. B says how many grams of sugar are in the smoothie that contains 320 calories. So we would find 320, and it is 70 grams of sugar. See what tends to happen to the number of calories as the number of grams of sugar increases. So as our sugar increases, if you kind of notice overall, our calories also increase. So that's what you would say. You could say they increase as well. Okay, so just based on that, you're going to try 1 and 2. Says how many calories are in the smoothie that contains 51 grams of sugar, how many grams of sugar are in the smoothie that contains 250 calories. So I'll kind of scoot back up a little because you can use this one as well. They're the same graph, just ignore the red lines. So you're looking at this same graph that we just looked at to answer 1 and 2. So pause the video and then I'll go over it with you. Okay, so number 1, how many calories are in the smoothie that contains 51 grams of sugar? So if we look, 51, go up, that is 260 calories. Number 2, how many grams of sugar are in the smoothie that contains 250 calories? We find 250, and I would say that is 52. Okay, so now let's look at, identifying correlation. So on this, a correlation, you're probably going to want to write this definition, is a relationship between the data sets. So we typically use a scatter plot to describe correlation, okay? But it's just how you describe a relationship. So if you notice, they give us 3 depictions. You can kind of draw these and just randomly put points. Don't spend a lot of time on it. But positive correlation, if you notice, the points tend to kind of group together in a positive direction. That's why it's called positive correlation. We're just determining their relationship is positive because they're all slowly increasing as a group. Obviously, it's not a straight line. Negative correlation, same thing. They're all kind of grouped together, but they're going down in a negative direction. Okay, it also describes it exactly like on positive. As X increases, the Y increases. The negative correlation, as X increases, Y decreases. And then this one, if you notice, the points are just super random. So there is no pattern, so that is called no correlation. So that's your 3 options to choose from. Positive correlation, negative correlation, and no correlation. Okay, on this next example, it says tell whether it shows positive, negative, or no correlation. So looking at the age and the vehicles owned, those are pretty random. So I see no pattern, so that would be no correlation. B is temperature in coat sales at a store. So if you notice, as the temperature gets smaller, temperature's down here, as the temperature gets higher, the coats sold goes down. So those are grouped together in a negative correlation. Okay, so I'm not going to make you do number 4. I feel like that's too much. Do number 3. So you might want to copy this table down first. You're going to make a scatter plot of the data. So you're going to graph those and tell whether the data show a positive, negative, or no correlation. When you're making your scatter plot, if you notice on the temperature, it starts with 68 as the lowest. You do not have to start at 0. On the graph about smoothies, if you notice there was a little like squiggle at the beginning, that means we're not starting at 0, then count by your pattern. So you could start at 60 and then still count by 5s or 10s or something. Just do that little squiggle. Okay, so try number 3, and then I'll go over it with you. On number 3, we're given this table. Temperature in Fahrenheit is our X, attendees in thousands is Y. So on your scatter plot, you just draw an L. So X is temperature. Have to label it. And Y is our attendees. I almost spelled that wrong. Okay, so then our temperature, if we kind of find our lowest, I see 68, and our highest is 92. So I'm going to count by 5s, starting with 60. I'm going to do a little to note that it didn't start at 0. All right. And then attendees, it goes all the way up to, I don't see anything above 5.5, so we can count by 1s on that. Okay, so when the temperature is 82 degrees, it is 4.5 thousand people. And you're just trying your best to graph these. I can't tell exactly where that is, so I'm not going to count it wrong. So go ahead and fill in your points if you haven't already. 78 is exactly 4. 68 is 1.7. 87 is 5.5. 75 is 3.8. 71 is 2.9. 92 is 4.7. And 84 is 5.3. Okay, so there is our scatter plot. And then it asks us, is there a positive correlation, negative correlation, or no correlation? So if you look at this, it kind of looks like they're kind of grouped together and going up. So that would be positive correlation. That's how you look at it. You just kind of look at generally what's happening. If you can't tell anything, then that's no correlation. Okay, let's look at example 3. Okay, next we're going to look at a line of fit to model data. So when the data shows a positive or a negative correlation, so only one of those two, it has to have some sort of correlation, you can model it by using a line of fit. So it's kind of exactly what it says. It's a line drawn on a scatter plot that is close to most of the points. So think of a line of fit as the line that best fits all the points. That's exactly what it is. So yours might be a little off from someone else's. That doesn't mean it's wrong. It's just you're trying to choose the line that best hits all your points. Okay, it's not going to hit every single one of them. That's the whole point of scatter plots. Okay, so the first you have to decide if it can even have one. So it has to have positive or negative correlation for you to draw a line of fit. So let's look at an example. So it says this table shows the weekly sales of a DVD and the number of weeks since its release. Write an equation that models the sales as a function of the number of weeks since its release. Interpret the slope and y-intercept of the line of fit. So they give us this. Here's our x, here's our y. So the first thing we would do is make a scatter plot. So they've done that here. They scattered the points. And there's 1, 2, 3, 4, 5, 6, 7, 8 points. And if you notice, we technically only went through 2. But this line was the best one to kind of be in the same direction as all of them. Your line of fit has to go through at least 2 points. If you notice, this one only goes through 2, and that's okay. But it cannot only go through 1 point. It has to go through 2 or more points to be a line of fit. So now from that, those 2 points that it hit, we can find slope. y2 minus y1 over x2 minus x1. Then, hold on, I'm about to sneeze. Okay, so now we found our slope. We can use our point slope form because we have a point. Neither one of them are the y-intercept though. So we have to use point slope form, this one right here. And we plug it in. So they used 6, 8. So y minus y1 equals the slope times x minus x1. Then we distribute to solve. When you do that and then move your 8 over, you get y equals negative 2x plus 20. So they asked us to draw a model and then a line of fit and interpret the slope and y-intercept of the line of fit. So now that's easy. Our slope is negative 2. Our y-intercept is 20. So if we looked at that, the slope is negative 2. That means the sales are decreasing by $2 million each week because they're in millions. And then the y-intercept has no meaning in this context because x is 0. That'd be 0 weeks. So that one doesn't really help us. But the slope tells us it decreases by 2 million each week. So we're actually not going to do an example over this. I think you kind of get the gist of this. So that's the lesson for today.